Okay, we're on the last page now of 10.1. We're in the Practice Plus section again, where these are problems where it combines more than one skill. It really is pushing you to where you are really ready to deal with any type of problem that they might throw your way. In this case, you can see by looking here, and I apologize, I copied the teacher version of this, so it already is showing the answers. See if you can ignore that and work this out here. But in this case, we can see that we're going to need to translate. Because of the section that we're in, we can expect there to be some sort of squared piece that we're then going to have to solve, because that's what we've been doing this whole time. So let's read it, take a deep breath, read it again, and start to translate here. Let's look at what they give us and what our goal is. The square of the difference between a number and 7 is 16. Find the numbers. Deep breath. Everything's so much better after you take some oxygen in. The square of the difference between a number and 7 is 16. Sometimes even reading it twice, it's like it's still just a bunch of words on the page. But we can start here. Find the numbers. So there may be more than one answer here. So we want to find our number, our x value. And let's see where they mention that. The square of the difference between a number and 7 is 16. So that number and 7, what were they talking about? They're talking about the difference between a number and 7. So we're going to be subtracting, and anytime they mention difference, it's always the first item mentioned minus the second item. In this case, it's going to be x minus 7. So the square of that difference, so we've got a difference that we're then going to square, and that is 16. There's our equal sign, equals 16. So let's put that all in place here. The difference is going to be that first item minus the second item, number and 7, so x minus 7. The square of that is 16. So there's our translation. That really is the hard part, because remember, by the time you get to these in your homework, you will have done so many of these solving. This part should seem at least familiar, if not easy by now. You should have practiced it so much. So we're here, the squared piece is all by itself. So now we go ahead and take the plus or minus square root of both sides. And the plus or minus square root does the job of undoing the square. So all it does is release what's inside the x minus 7. Fly, be free, out into the wild. And then we have two options for our plus or minus radical 16. You get positive 4 and negative 4 as your two answers. So our two situations are that x minus 7 equals positive 4 and x minus 7 equals negative 4. And when you solve that, add 7 to both sides, you get x is equal to 11. And over here, add 7 to both sides, you get x is equal to a positive 3. They both check. 3 minus 7 is negative 4, and square that, you get 16. 11 minus 7 is 4, square that, and you get 16. So both of these work, so you can write that as x equals 11 and x equals 3, or you could put that in set notation, 3, 11. Order doesn't matter here, it's not a point on a graph, it's just a collection of numbers that all work in the same equation. That's what set notation does, it just puts it together. Okay, and then for number 66, it says to solve the formula for the specified variables, one of the things that I didn't type on here, very important, is that only use the principal square root. It says that in the directions. Because of the particular formulas that we're using, the variables are all going to be positive, so we don't need to use the negatives plus or minus. We can just use the principal or the positive square root. So that's what that means, only use the positive there. So in this case here, we're solving for r. That means we want to get r by itself. Well, the intermediate step that we want to do is really get the squared piece alone. So we want to get the 1 plus r squared alone first, and then we can take the plus or minus square root of both sides. So what's in the way here is it's being multiplied by p. So we'll go ahead and divide both sides by p. And that leaves me with the 1 plus r squared. And because that's what we're solving for, I'm just going to move it to this other side here. 1 plus r quantity squared equals a over p. Hopefully that doesn't throw you too much. And then I get to take the plus or minus square root of both sides. And that undoes the square root. So we're just left with, we release out into the wild the 1 plus r. And then we have plus or minus square root of a over p. And right there we get a chance to apply that, only use the principal square root. I really didn't even need to do the minus here at the beginning, but we're catching it now. The instructions are telling us to only use the principal square root, which means only use the positive. So we've got 1 plus r equals positive square root a over p. And now our goal is to get r by itself, because that's what we're ultimately solving for, is to resolve the formula for r. So we subtract 1 from both sides, and we get r equals square root of a over p minus 1. Now if you did -1 plus radical a over p, that's the exact same thing. What we can't stop with, though, is the fact that we've got a radical in the denominator here. So what we really have is r equals radical a over radical p, and it's still minus 1. We want to go ahead and rationalize the denominator. So we're going to multiply by radical p over radical p, because it doesn't change the value, we're just multiplying by a value of 1. What it does do is allow that denominator to be a whole number here. So radical p times radical p is just p on the bottom. Radical a times radical p, those get to mush or combine together under the radical ap. And then still just minus 1. So our final formula is r equals radical ap, the whole thing over p, minus 1. And that sort of fits. Sorry, it went off screen a little bit, so let me adjust it so you can see that for just a moment. And then we'll talk through the bottom of the page here to finish this out. So the application exercises, I'm not going to walk through them. I just wanted to give you a little heads up, little thinker alert here, like for number 72. And we've talked about this before, but you always want to read above for any information or formulas they give you. So if your eyes on the page go directly to number 72 in the book, you'll see if the area of a circle is 49 pi square inches, find its, this got cut off, sorry, find its radius. I should do that in black to make it more visible here. Find its radius. Well, that's all fine and good, and you're going, well, wait a minute, there's got to be more information there. There is. They're giving you this formula. Use the formula for the area of a circle, area equals pi r squared. So that's what you use, and then they give you, if we were to do 72 here, the area of the circle is 49, so area right there gets replaced with 49 pi, and then that's equal to pi r squared. So the area gets replaced, there's the pi r squared. Now you work to solve for r by first getting r squared by itself, then taking this positive square root of both sides. We're talking about a measurement here, so we don't need to do plus or minus square root of both sides, just the positive square root of both sides. And of course you'll do some review and some preview exercises. So again, that was just a little bit of a thinker alert. Just wanted to give you a heads up that the formula is up above the problems. Look for that. And then we'll see you in section 10.2. And just again, 10.2 is going to be a bonus. If you choose to do that problem set and complete it, it will be worth a bonus problem set for the term.